Thank you so much. First of all, thank you, Bergen, for inviting me and for the lovely weather and for the lovely hike yesterday up in the mountains. I didn't die like I thought I would more than 10 times, but I made it through, so yeah, I'm here. So I'm going to do this a bit in reverse because I know people, leave because, it's like 40 minutes talk. And I'm going to do a selfie with you, and you can say, Bergen, Bergen. Cool. So that usually makes people laugh, and it's a positive thing. So before getting started with the introductions, I want to ask you who from all of you went to PromCon last week at Munich, Germany? Cool. So yeah, so that's obviously PromCon is Prometheus focused conference. They usually do it in Germany because the founders are from Germany. But yeah, we tend to discuss other open source project related to Prometheus. So I was there for the very first time in my life, and that was super, super interesting. Lots to learn. So about myself, I'm an SRE in observability turned developer experience engineer. I discovered that actually going to conferences and speaking about the hardships of an SRE life, it's a lot more relaxing than being on call and dealing with production incidents. So after a couple of years of going to conferences, I decided to do the switch full-time. So here I am. I'm an organizer of Cloud Native Days Romania. So if you don't know on the map where Romania is, now you have the chance to submit your CFP, go visit it, and eat good food. Yeah, the CFP is going to open in December. Also, I'm a contributor to OpenTelemetry CNCF project, and I do a bunch of other stuff in the meantime. All the slides are ready for download at the GitHub, so in case you don't want to stick around 40 minutes, there you go. So the agenda, I framed a bit differently. We're going to talk about Cardinality a lot, obviously Prometheus, to be or not to be Prometheus. My next superhero, we're going to see a demo, live demo, and then I'm going to wrap it up with some motherly advice. So back when I used to be an SRE, I'm sure that lots of stories start like this. When I used to be an SRE, I often saw a lot of lagging systems. And they were lagging, and people started crying. And when they cried, they noticed that the monitoring was super slow. And we were thinking okay, but what are the root causes? What happens? Did I did something wrong? Why are all these alerts happening? Well, the culprit seems to be this guy. Well, not the actual actor, but Cardinality. So Cardinality actually drives can be low cardinality, high cardinality, basically represents the number of unique time series. So if you're dealing with observability, you know what's cardinality pretty much. So high cardinality will drive the high number of time series and usually will cause a mess in your observability system. So why is it such a pain in the... Because it increases resource consumption, like storage, memory, CPU, drives it's a slow query performance. You're gonna get tons of alerts, and basically it's gonna handicap your alerting, your actionable insights. So anyway, from experience knowing about high cardinality, yeah, it usually messes one's life up. Back in the day when Prometheus came, we all looked with these gleamy eyes full of hope and excitement, and actually was and it is a really, really cool project because it's very efficient, it's focused on metrics, and yeah, it saves our lives a bit. So just to wrap it, going back and explain a bit how Prometheus works under the hoods, it's a metrics-based monitoring system, right? It doesn't really connect, it doesn't connect at all with any other signals, so it doesn't have anything to do with logs, profiling, events, traces, so it's only focus-based, and it operates with a pool-based model, right? So it scrapes basically everything and will ship it towards its time series database. So Prometheus acts with these elements, these components. So it has a time series database, an alert manager, web UI, obviously API, node exporter, and the rule manager, script manager as well. So it's really cool. PromQL comes with a Prometheus query language focusing on 4 metric types, and overall does a very, very good job. It's very efficient, right? So it saves a lot of time in our monitoring overall observability system. However, it doesn't come without, let's say, deficiencies, and we're going to explore that. Before we're going to explore that, we're going to ask ourselves, so basically what happens with the issues in your observability? So once you have like small problems and you're a company and you want to scale, what happens with those tiny issues that you already have in observability? What's your like immediate guess? Perfect. So they also scale, and we're going to have like a bunch of explosion in telemetry data. Then we're going to have blind spots, cardinality problems, operational consequences. So pretty much whatever was small before is going to be big after, right? So that's scalability for you. Is going to bring a lot of issues. And here, high cardinality is such a big problem because it always comes from tiny issues, right? So from tiny issues that we could have prevented before, we could have like dodged the bullet before, but normally like we don't do it. And when we actually scale, we realize it too late. And I want to hear like we're gonna see exactly what drives this high cardinality. Mainly will be the labels with a large number of unique values, like user ID, session ID, request ID, IPs, etc. The overscraping or overtagging techniques, and exporters that tag too much, unique IPs and device IDs. So we're going to take a few examples and we're going to see how it is. So when you define your scrape job in Prometheus, you're going to define there the scrape interval. And like sometimes people don't really think that the scrape interval in Prometheus needs to be synchronized with the metrics interval when they change. So the metrics, let's say by default, normally they change, I don't know, every 30 seconds, 60 seconds, 15 seconds, right? So if you're gonna have a scraping interval in your scrape job that is lower than that, you're gonna do the over-scraping part. So you're gonna over-collect, you're gonna have to ingest a lot of stuff in your time series database, and you're gonna drive the CPU and the network usage, so it's not good, no. The over-exporting is going to happen when you can attach too many labels, unique labels, and obviously you don't want that. Who wants to have like, I don't know, user IDs, millions of user IDs or regions, or I don't know, job instances, like instances IDs or something like that. So those are like hard no, and definitely you don't need to do that. And over-tagging is pretty much like the same idea. Then if all the node exporters, collectors are enabled, all the metrics will get multiplied. So what should you do? What should you do? Well, let's see about Prometheus, because it's a very, very good use case. The Prometheus comes, like we already know by now, so it's not like a mystery and I'm gonna unravel it overnight. It comes with limitations. So one such limitation is cardinality. So we can do a bunch of stuff to optimize Prometheus and dodge bullets around those limitations. So we can apply for cardinality only. We can optimize with good labels, right? So remove those unique label IDs. We could use the label drop, set limits on the scrape jobs, or synchronize the scrape jobs. We can do the long-term storage. Improve the architecture like sharding, federation, high available replicas. That always works, and I talked to many users and they're already using that, so it's fine. You could use like something that I found, well, not recently, but it was like very interesting concept to dig in the scrape jitters, which are actually the most common cause to oversize time series database blocks. So that happens like when the scrapes do not occur at consistent intervals. Normally they're like 2 milliseconds, a few milliseconds there, and you can use, for example, observability scrape jitter and find out where you have issues with your jobs and the scrape jobs. That's I mean, obviously 2 milliseconds here doesn't sound so much, but it causes quite a lot of issues if you're if you want to identify and go actually in a lot of detail. You can use another tool that is really, really cool by the Go project that came out from Google. That's profiling proto. And it's good because you can do, for example, top, like here in this in this example, and we'll show you in a lot of detail, like what it collects, how you can visualize it, the performance data basically from your running application, so you can see like where Prometheus spends time in the memory, and basically that will be very, very useful for debugging and optimizing. Another tool is called Prompt Tool. Those are real classics, so I don't want to spend too much time on these ones. It's just a reminder like what you can use to optimize Prometheus. Recording rules are the classics for Prometheus. They enable the pre-computation of the expensive queries. Very, very interesting concept in the Prometheus landscape. Everybody is using that, but don't overuse it, right? So when you start having a lot of recording rules, that also can basically make, let's say, your life worse, because then you have to manage all of those, and it's not going to be easy, right? And overlogging is another way to do it via the configuration file with query log file setting, and also something that's useful because you can find like the queries that are interesting to find out the queries in the Prometheus, right? You could add query limits as well, especially when you want to restart the Prometheus. And you can use the tune garbage collection as well. So there are like little optimization techniques that you might have known about them or not. It's good to have a refresher. And also Go memory limit setting is the same from the Go package, the Go team. So that's really nice if you're working with Prometheus, but at some time it will be the scaling. I mean, Prometheus will not be able to scale in such a way that for you will manage it properly, right? So it's going to come a time and a use case when you're going to ingest lots of metrics and you're not going to be able to handle it. Even when you apply all these like optimization techniques and you're going to, you know, add more Prometheus instances, it's still not going to be enough. So right now, I'm going to present you the VictoriaMetrics. I'm not sure how many of you already played with VictoriaMetrics or if you use it in your organization. VictoriaMetrics is an open source project, so that came because they saw these issues in Prometheus and they wanted to address them, especially about the scalability, the cardinality. So this is what was the actual idea, the origin story, right? So the superhero, in a way, came like from the idea of addressing the issues and started with VictoriaMetrics. Right now, since last year, they have Victoria logs in production, and currently under development, they have the new signal Victoria traces. And right now, obviously, we're going to focus only on the open source part because that's what we are interested in. So it's cool that VictoriaMetrics is compatible with Prometheus and with Grafana, so you don't need to like change anything, so you can stick with whatever you already have there in your stack, in your observability stack. So it does the push and pull support without any limitations. It also has like in plus clustering support with multi-tenancy, lightweight metrics collector, and we're going to see that a bit later, backup restore utilities, and authentication proxy. So right now, we're going to see a bit how data ingestion is happening under the hood. And we're going to see like specific unique components of VictoriaMetrics. So here, if you already know Prometheus and you know how to do a scrape job, I'm not going to tell you how to do that. Pretty much you can do it with Prometheus agent, or you can use VM agent. That's the VictoriaMetrics agent. It's a lightweight collector agent, and it's cool because it receives the metrics that the application pushes via popular protocols. You can use like, I don't know, InfluxDB, Graphites, Datadog, whatever you want. And once VM agent collects the metrics, it will process them by filtering unwanted data, changing the labels, combining multiple labels, metrics together, and force the processed data to one or more remote storage systems with the help of the remote write protocol. So this is the part that basically takes the data and shifts it towards the VM insert. This is where the VM insert, where the ingestion happens. And from the VM insert is pushed back into the VM storage, where it's going to be stored for long-term, basically. And then it's going to be shipped to VM select that handles the query part. So this is where the user basically interacts with the user interface in the VictoriaMetrics UI, either with Prometheus query language or Metrics query language. So this is how the data ingestion happens under the hood with all these unique components. And we're going to see everything like in a live demo to show you how it's linked in the user interface. So it's not a surprise. So there are benchmarks actually proving the efficiency of VictoriaMetrics over Prometheus. So you can have like CPU usage, disk usage, memory, read latency, and so on. That score higher than Prometheus. They are published on the GitHub. You'll have them in the resources. You can run them and see exactly for yourself. A very important add here from VictoriaMetrics is the stream aggregation concept. That's different from the recording rules in Prometheus, is that it differs from the recording rules in a way that basically the aggregation happens before actually the data enters the database, right? So that makes it more efficient and more flexible and saves time, basically. That's why it's faster. So it's a very interesting concept that actually there's a whole talk about stream aggregation. We can leave that for later. But just for you to gain something new from today is that it's similar with recording rules, but because it processes the data before it hits the database, is faster and more flexible. It also, VM agent brings network costs, so brings a lot of efficiency from the network side on the monitoring with the increased compression levels and the batch size leading to better compression. So that's in plus. So right now, I think we reached the time for demo. People can breathe, and I'm gonna share my other thingy here, screen. Yeah, 1 second. Oh. Right, so here is the VictoriaMetrics UI that I wanted to show you that, so obviously you don't find this anywhere. This is a playground, so you can access it and use it right now. If you go to Play VictoriaMetrics, it's the same view that you're gonna get as myself. And here, especially related to cardinality, there's a feature called Explore Cardinality. So if you go to Explore Cardinality, you can see here the metrics name with the highest number of series, meaning the metrics that are the most expensive. So imagine that you have your own infrastructure with your own metrics, with your own VictoriaMetrics installed locally and so on, and you want to find out, okay, but what is driving this cardinality? What is happening? How can I do it better? You can look here in the Cardinality Explorer and see the metrics that are the most expensive, and also correlated with an interval of time before that. So right now, everything here you see is for the last 24 hours, and you could go at the dates and check how it compared with the previous week, how it scored. Is it rising or is it it's going lower? And you can check the most, let's say, expensive metric and see the label with the highest number of unique value. So if you remember the label with the highest number of unique value, that's the label that actually multiplies the time series, right? So in this case, for example, let's say the resources will multiply this query right here 136 times, right? So imagine that you have really high numbers and you want to use the label drop or you want to do relabeling. You can come here and find out, okay, yeah, this is the top labels. I will do this and I will start addressing this directly in my scrape job. So that's very handy for you once you want to go in deep and troubleshoot. The same down here, you have the labels with the highest number of unique values again, and you can see correlated with specific label values, right? And for example, you want to see a raw query, you just take the query here, and you can execute the query. And you want to trace the query. That's also something useful that you could do here directly in the UI. You execute it again, and here you get all the information specifically for your query. So I don't know, if you have some issues with your query, you don't understand what is happening, you could always go here and have it in the user interface. And you could also save the trace to JSON. You can go back, use the trace analyzer, upload the file, and here in the downloads, you can upload it and view it as a whole here. So that's just related to the traces, right? You can also use the top queries. The top queries will show you that what are the queries most summary time to execute. So the queries that are most expensive, they drag too long, they cause latency, and you can see here the sum and duration. And obviously you can execute it and see how it went, when did it happen, when it spiked, so correlated with your own dashboards. There are other things that are super useful here. I'm not going to go in deep down because it's going to take too long, but you have like other useful things that everything you can document and read the documentation. Something new that was introduced also is the alerting rules. That could be something useful for you. And like I said, you can use the VictoriaMetrics Playground Grafana to visualize everything and understand, okay, how you want to check specific queries or specific dashboards, and correlate it with what you saw earlier in the Cardinality Explorer. So I'm just going to go back to the presentation here. Okay, so like we've seen, the Cardinality Explorer, will help us basically get all those actionable insights about the metrics, the most expensive metric, the labels with a unique value, and that's something useful to have alongside other features as well, unique features as well. So it's something unique. It's nice to have. So I did this slide at PromCon, and they kind of almost left immediately. I want to see your reaction. Oh, okay, some of you were looking at their phones. Yeah, so it's funny because like the whole battle sort of between VictoriaMetrics and Prometheus, ever since I joined VictoriaMetrics, they asked me, okay, but like what's up with these people? You know, it's like they are they in competition or something? It's like, I don't know. I have no idea. So I started, I created this slide and everybody laughed at Prometheus. They thought it was a good joke. So yeah, they're in competition, but they're not, in the sense that there's always going to be a technology. There's always going to be a project that's going to address let's say, the weak points of another project. And I think that's good for the users, right? I mean, it's not actually like for somebody, it's like for the users. If in your organization, if in your team, you're using a project that actually addresses some issues, then why not? You're going to test it, you're going to benchmark it, you're going to try it out, and that's good for life in general. So from my side, I think that was pretty healthy to do in technology all the time. And I want to reached the second part right now. We're like almost at the end about the MetricsQL. So like I told you before, Prometheus uses the Prometheus query language. VictoriaMetrics uses, let's say, more enhanced MetricsQL query language that's totally PromQL compatible. You don't need to change any dashboards or alerting rules, but comes with 100+ additional features, functions, sorry, that it's meant to improve the experience, the querying experience for the user's life's sake. I put there some top 5 features. I'm not sure if I did it justice, but you have a QR code there so you could check the documentation for MetricsQL. It's a really rich query language, so it's pure mathematics. I'm not gonna lie to you and say I'm an expert. And here I'm gonna use it for in some Grafana dashboards that I want to show you, like in case you do have high cardinality issues and you struggle with that. You could check out some specific things related to VictoriaMetrics component. So you remember I talked about the VM storage, so that's the component that handles the long-term storage. In case you have high cardinality, VM storage is going to be impacted by it. So you want to check, like in the dashboards, if you have spikes there, and you want to find out if you have spikes and they're in direct correlation with high cardinality. So you can check this dashboard out. Obviously, the CPU usage for VM storage, so definitely is going to be impacted by it. So check it out for spikes. VM select, so at the query level, you're going to have also issues. That's also very good to see. And VM insert. So the VM insert is the one that connects with multiple VM storage nodes, and is going to fill the loads of high cardinality. So this is where you're going to see like ingestion latency a lot. You're going to see the spikes there. So it's very useful to know, in addition to the Cardinality Explorer that I showed you earlier. One useful query that we use also internally at VictoriaMetrics is because I'm a bit blind, so is the VM new time series created total metric from MetricsQL. It will show you like how many brand new unique time series were created, right? So in case here you have like spikes, you're gonna see like going like this, it's going to be a direct implication of high cardinality. We use it actually in a dashboard. This is internal. If VictoriaMetrics use it, you should use it too, right? So it's pretty good because it will show you the churn rate. So if you're going to see, for example, like time series created and also dropped, removed a lot, you're going to see it in this particular dashboard. So that's not always a good sign, right? Because high rate churn usually means that something is happening, and it's also can be a direct correlation of high cardinality. So if you do ask me for a motherly advice, so at the end of all this presentation, what should you do? Should you use Prometheus? Should you use VictoriaMetrics? I would say it's really, really up to you, right? Like I said, Prometheus will come with very known limitations. Obviously, you could do a lot of optimization around it. With scalability, you can use add more Prometheus instances, lots of the techniques that I showed you earlier, but you're gonna have the use case when you're gonna ingest millions of metrics a day, and basically that all the optimization in the world won't help you, right? So I would say you do you, basically. You test it, you do the benchmark, you try it out, you see if it's efficient, how it is efficient, and how it helps your life, right? Like I said, there are so many things you can try out. VictoriaMetrics, in my opinion, is a complex ecosystem. It's quite advanced in the sense that it comes with a lot of new information, like MetricsQL is very performant. It comes with new features, unique features, and only the part of data ingestion that I showed you is quite interesting. So I would say to stop by and try it out. It's open source, and it will definitely help you if you have these issues with metrics and so on. The resources here are something useful. And like I said, you can use the QR codes to find out more about the metrics, logs, and traces. And yeah, the community is really, really helpful. So I love there because you can contact us via Slack. You can ask questions. If you struggle with an issue, you can open an issue in GitHub. So they're really, really helpful. And yeah, that's it from my side. I hope it was useful for you. And thank you so much. Early. Oops.
All right. Anyone has a question?
No.
Yeah. Please go ahead. Me? Yes.
This cardinality measure, is it built in, or do you have to define it separately?
What do you mean? Is it built in?
Do you have to define how the cardinality is measured, or is it built in, but it just picks up this data automatically?
Yeah, I don't think I understand it in the cardinality. Do you mean like the user interface, what it shows you there, or
Yeah, the data.
the data? Yeah, well, in this particular case, like I showed you the demo, so all the data is taken from a playground. So imagine that you have your own workloads, and we'll show you the metrics that you are using, because the VictoriaMetrics interface basically will use a scrape job, just like Prometheus. It will take all the metrics and will populate it and will show you in the user interface. So it will know what metrics basically you are using and everything. So I wouldn't say you need to do anything extra in the sense to find out all that information about cardinality. You use it with your scrape job, and that's it.
Any other questions? Yeah.
How does VictoriaMetrics fit within the UTEL landscape?
Yeah.
Or UTEL metrics?
Yeah, of course. Thank you for asking. Yes, so I'm going to go back. I put there because I anticipated your question. I'm a mind reader, actually. So yeah, no. So VictoriaMetrics has so it's compatible with OpenTelemetry. Created so yeah, it operates with OpenTelemetry. We can use it, but it's open source. We also forked the OpenTelemetry demo and used it for VictoriaMetrics like other vendors. So basically, you could use the OpenTelemetry demo to see through that demo how VictoriaMetrics works, Victoria logs, Victoria traces. And yeah, basically it's compatible, so definitely 100%. And we also, but I'm not going to speak about it because it's enterprise. So definitely 100% we support OpenTelemetry, and we hope many people can use it.
Any other questions? We have 5 minutes, so we have plenty of time.
If not, I can sing and dance.
Okay.
Yep.
You did the comparison with Prometheus. How about the comparison to Mimir?
To Minio.
Mimir.
Mimir, yeah, there is actually from the founders, they already benchmarked it. So if you go to the community, there's a whole benchmarks with Mimir, Tarnos, and other open source projects. And yeah, there are articles explaining all the same for Prometheus, but for the other open source project, yeah, no. And Elastic as well for logs.